Hello, welcome to In 5 Minutes. BJT is nothing but the bipolar junction transistor. Now we'll start with the discussion of BJT. What you look over here, you have a three terminal device called as emitter, base and collector. The three are written over here. You have emitter, base and collector. These are called as three terminals of the bipolar junction transistor. Then it has two PN junctions. When you look at the diagram, this is one of the PN junction and this is one of the PN junction. So it has two PN junctions, you can say. So it is a, what you can say, two PN junctions and three terminal device. Now how is the arrangement of the emitter, base and collector? You can see emitter, base and collector and the doping concentration and the area of the three. You can see emitter, the concentration of electrons is very high. This is nothing but a PN junction diode, you can call P type and N type. Here the doping is more. What do you mean by doping? That is adding impurity. Why we add impurity? To create more number of free electrons. Now why the emitter should have the large number of electrons in it? Can you imagine? Heavily doped. Why we require heavily doped? Because the main current of the transistor is due to electrons and which are emitted by the emitter, so we require high doping for the emitter. Then what you can see, doping concentration very high and the size is moderate, right? Then going to the base is very thin. You can see base is very thin and lightly doped, that is doping is less in base because it will not hold the free electrons for larger amount of time. Whatever it is receiving, it is carry forward the electrons to the N type and finally to the supply, whichever is connected, right? So the area for the base is very less and what you can say, it is lightly doped. Then coming to the last part, collector. Function of the collector is to collect the electrons. So in order to collect the electrons, it should require largest area amongst the three. The largest area is for the collector and the doping over here, what you can say, is moderate. So the highest doping is for emitter, then the highest area is for collector, then size is moderate for emitter, thin for the base and largest for the collector. This is the basic, or you can say, the constructional detail of NPN. This is nothing but the, you can call it as constructional details of BJT. Now coming to the two diode analogy, what you can see here is NPN transistor which has the emitter, the base and the collector. Now I can break this P into two halves, so I can have one PN junction diode and the other PN will form another PN junction diode. So this is nothing but the two diode analogy of the BJT, right? This is for NPN, right? You can see the two P's are connected together to form one P and you have two different ends which will form the two ends of the NPN transistor. Similarly, we can go for PNP. PNP. What you have in PNP? You have a PN junction diode. What you can say over here? Two ends are joined together to form a single N. That will give you the center N. Then you have two P's, the P over here and the another P over here, that will form the two P's for the PNP transistor. This is how you can analyze the transistor as two diodes connected back to back for NPN and like this for PNP. Now the various operating modes of the BJT, what you can say is the BJT, bipolar junction transistor, can be operated for different modes. You can say active mode, saturation mode, cutoff mode, reverse mode. Now what are these applications? For active region, you need to make, now what is JBE is the base emitter junction. When you look it over here, this is your JBE. I have shown you two PN junctions, so this is your JBE, junction between base and emitter, and this is your JBC, which is the junction between base and collector, right? If you want to operate the transistor in the active mode, you need to forward bias the JBE, that is base emitter junction, and reverse bias the base collector junction, so you can use the transistor as an amplifier. Now saturation में you need to forward bias JBE, forward bias JBC. That means you are forward biasing both the diodes, right? So saturation is completely on, the transistor is completely on. Cutoff में you are reverse biasing both the junctions, so the transistor is continuously off. And the last is reverse active, that is JBE which was forward biased is now reverse biased, and JBC which was reverse biased is now forward biased, and this is used in integrated circuits. Combining these two on and off, the transistor can be used as a switch. So this is one of the application of the transistor. You can use it as a switch, or you can use as an amplifier, or you can use in integrated circuits. This is the basics of the bipolar junction transistor.